Okay, good day, students. Today being Monday, the 11th day of August, we are beginning our preparations for the next year's exam. And if you follow the classes step by step, I assure you, you will come out with a very good grade that will give you admission into the university come next academic section. Okay, we are beginning with physics, like I said in the first video, and today we are looking at electricity. Electricity is a topic that is constant. If you check the trend of questions in JAMB examinations, you see that there's no year you will not see a lot of questions under electricity. In electricity, we talk about production of current. And for electric current to be produced, it can either be a direct current or an alternating current. A direct current is a current that is produced from a cell. When we talk about cell, we are talking about battery. Any current that is produced from battery is a direct current, whereas current produced from a coil is alternating current. For example, current produced from the generator is alternating current. Current produced from the transformer, like the geometric light that we use, is alternating current because it is generated in the transformer. Now there are two types of current, like I have said. It can either be direct current or it will be alternating current. Whichever one it is, there are components that are always in electric circuit. Let's first take direct current. Under direct current, we are talking about currents that are produced from a cell. And in this direct current, there are components that form the electric circuit. Components like the resistor. The resistor is a component that offers opposition to the flow of electric current in the circuit. We also have the potential difference. The potential difference is the potential energy between 2 points in the circuit. The potential energy between 2 points in the circuit. And what produces the potential difference is the cell. And we denote the potential difference with V, while we denote the resistance with R, capital letter R. The resistance is coming from the resistor. That means it is the resistor that produces the what? The resistance. Now, whichever current we are talking about, whether direct current or alternating current, we have these components that we talk about. Now, these resistors are connected in the circuit where a cell is also connected. Once a cell is connected and there is a resistor connected, or resistors as the case may be, connected in the circuit, then current is bound to flow. According to Ohm's law, what did Ohm's law state? It states that the current passing through a metallic conductor at constant temperature is proportional to the potential difference between its end. Now, meaning that from Ohm's law, as the potential difference increases, the current also increases. What does it simply mean? When you bring a battery, maybe a finger battery, and you use wire and connect at both ends and then bring it to a bulb, You have formed an electric circuit because the bulb will lighten up, showing that the potential difference has been supplied by the battery, and then the current flows through the metallic conductor and powers the bulb. So that is an example of electric circuit. And we are saying that when this electric circuit is connected, it means that current has started flowing. And from Ohm's law, when you increase the battery to 2, then higher current will flow. That means the more the battery, the more the current that flows in the circuit. In other words, we are saying that the more the potential difference, the more the current that flows in the circuit. And from your direct variation in mathematics, it simply means that the potential difference varies directly with the current. Then you bring in the constant of proportionality. That constant of proportionality is what we call the resistance in the circuit. So, having said this, let's look at how electric circuit can be. Okay, this is how an electric circuit looks. This is the symbol for resistor. And the resistor offers the resistance to the circuit, and which we denote with capital letter R, and is measured in ohms. So this is the symbol for ohms. Whenever you see this, it means ohms, the unit of resistance. Now the capital letter A here is showing that an ammeter is connected. What is an ammeter? An ammeter is an instrument that measures electric current. Just like we use some other instruments to measure some things, like using thermometer to measure temperature, we use an ammeter to measure the quantity of current that flows in the circuit. And this symbol denotes the cell. This denotes the two terminals of the cell, positive and the negative terminals of the cell. So this is how electric circuit is. So this is how electric circuit is. This one is the cell. What it means here is that only one cell is connected here, because this is denoting the positive and the negative terminal of a single cell. And the cell is what supplies the potential difference, which is measured in volts. Alright, having said this, the next thing that will come into our mind is, how does this connection occur? There are two ways of connecting resistors in an electric circuit. You either connect resistors in series, or you connect them in parallel. In an electric circuit, you can connect resistors of different magnitudes, that means different values. For instance, you can connect 2 ohm resistor, 5 ohm resistor, 3 ohm resistor together in a circuit. But if it is a cell, you can only connect cells of the same magnitude. That is why in your remote control, you cannot just bring remote battery and also bring finger battery and use it to power remote. No, they must be of the same magnitude. That means if we are talking about potential difference, then we are saying that the cells that will be connected must be of the same value. Then when we are talking about resistance, the resistors can be of different value, whereas the cell must be of the same value. Now, connection in series. Excuse me. When resistors are in series, These are 3 resistors that are connected in series. 2 ohm resistor, 3 ohm resistor, and 5 ohm resistor connected in series. So this type of connection is series connection. Like I said, that resistors of different magnitude can be connected in a circuit in series. But if it is cells that are in series, if cells are in series, we will have something like this. For example, I'm using 2-volt cell. Like I have explained, you cannot have 2 volts here and 3 volts here and 5 volts here. No. Because these are cells. They must be of the same magnitude. So you have 2 volts, 2 volts, 2 volts. They are connected in series. Now, for every series connection, whether we are talking about resistors in series or cells in series, the resultant resistance, what do we mean by resultant resistance? That means the total resistance in the circuit is obtained by adding the resistors. That means that our R, which is the resultant resistance in the circuit, will be equal to R1 plus R2 plus R3. Whereas, when we are talking about cells that are connected in series, it's still the same way. We get the total potential difference in the circuit by adding all the potential difference. That is to say, we have V, which is the resultant potential difference, is equal to V1 plus V2 plus V3. That is for series connection. We are not going beyond series connection today. We will show how a question looks like in series connection, and then once we do that, we now solve the question, how it looks like, and I will give you the ones you will try when resistors and cells are connected in series. And then you will solve it, and once you solve it, you upload your solution. Show me how you got your answers, and I will look at it, and then we make corrections where necessary. But this is how resistors are connected in series and parallel. Okay, like we said, that we have shown how resistors can be connected in series and how cells can be connected in series. This is a typical question where both resistors and cells are connected in series. The question says 3 resistors, 2 ohm, 3 ohm, and 5 ohms are connected in series in a circuit where 3 cells, each of 2 volts, are also connected in series. Calculate 1. The current flowing in the circuit. 2. The quantity of charge if the current flows for 2 minutes. Okay, the first thing to do is to show the circuit diagram. Picture the circuit diagram in your mind, and it is something like this. Two ohm, 3 ohm, 5 ohm. Like I said, this is series connection. And then 3 cells, each of 2 volts. Okay. 2 volts, 2 volts, 2 volts. That is how the circuit looks. And In some cases, instead of asking you the current flowing in the circuit, they can ask you calculate the reading of the ammeter. When you hear calculate the reading of the ammeter, it's the same thing as asking you the current that flows in the circuit, because I have said initially that ammeter measures current. Okay, so there are two things we are looking for here. We are looking for the current flowing in this circuit, and we are also looking for the quantity of charge in this circuit. We begin. First, we get the total resistance solution. So from what I said, effective resistance in the circuit, which is the resultant resistance, is equal to R is equal to R1 plus R2 plus R3. This is R1, this is R2, this is R3, which simply means 2 plus 3 plus 5, which is equal to 10 ohms. That means that the total resistance, the effective resistance in this circuit is 10 ohms. We now get the effective potential difference. Like I've said before, that V denotes the potential difference, and it is supplied from the cell. So the effective potential difference is V is equal to V1 plus V2 plus V3. And V1 is the same as V2 and same as V3, like I have said. So that will now be 2 plus 2 plus 2. And that will give us equal to 6. Now, we have found the effective potential difference and effective voltage and effective resistance in the circuit. We now recall Ohm's law that I mentioned initially. And that Ohm's law says that the potential difference is directly proportional to the current. And then we put the constant of proportionality, like you are solving direct variation. And that is simply V is equal to IR, where V is the potential difference, I is the current, and R is the constant of proportionality, which is the resistance. So this equation here is the equation that denotes the Ohm's law. So mathematical representation of Ohm's law is V is equal to IR. And when we have done this, the next thing now is to make I subject of the formula. Since we are looking for the current, we will make I subject of the formula, meaning that R crosses over this side. Since it's multiplication here, once it crosses over this side, it will become division. Or you can also say divide both sides by R. It's still the same thing. There are so many ways to kill a rat. Okay, so we make I subject of the formula is going to be V over R is equal to I. Now that's an expression for the current. Now we substitute the value. What's the value of our V? The potential difference. It is 6. And what is the value of our R? It is 10. When we substitute, we will now have 6 all over 10 is equal to I. And 6 all over 10. Let me teach you how to divide without calculator. You know, some students don't have the basic foundation in mathematics, primary foundation. And in exams such as JAMB, you can only use the on-screen calculator. So you are at advantage if you can use or solve the mathematics without the on-screen calculator, because it saves you time. Simple mathematics like 6 over 10. What do? All you just need to do is to know that 6 is the same thing as 6.0. Now, when you are doing division, you move your decimal point to the left. Then when you are doing multiplication, you move your decimal point to the right. This is simply saying 6.0 over 10. You know that 6.0 is the same thing as 6 because 0 is nothing. Okay, so when we want to do this division now, we move this decimal point to the left. And once you move it one decimal place, you cancel the 0 down. And that is going to be, this decimal point is here now. So what are we having now? 0.6 over, we have cancelled this 0, over 1. 0.6 over 1. And what is before the point? Nothing. So it means that we have 0.6. Anything divided by 1 is that same thing. So the value of our I now is equal to what? 0.6 amperes. The current is measured in amperes. Remember what I said? Resistance is measured in ohms. Potential difference is measured in volts. And then the current is measured in amperes. So we have found the first thing they asked us to find, which is the current. And the value of the current is 0.6 amperes. Now, having found the value of the current, we proceed to finding the quantity of charge flowing in the circuit. How do we find the quantity of charge flowing in the circuit? Quantity of charge is denoted by capital letter Q. And we say Q is equal to IT. That means that the quantity of charge in a circuit is equal to the product of the current in the circuit times the time in which the current flows in that circuit. Okay, since we have now found the current flowing in the circuit to be 0.6 amperes, and already in the question has given us the time to be 2 minutes. Now, since the question has given us the time as 2 minutes, we have to note that from the fundamental quantities and their units you did in your first year in senior secondary, SS1, you know that the SI unit, that's the System International Unit for measuring time, is in seconds. So every time given in a unit different from seconds must be converted to seconds. And how do we convert? We know from nursery school days and primary school days, we recite it 60 seconds make 1 minute, 60 minutes make 1 hour, and so on. So we know that 60 seconds is equal to 1 minute. And then the question has given us the time as 2 minutes. What does it mean? It means 60 into 2. The first 60 is for 1 minute. The second 60 is for 2 minutes. That's simply saying that T is equal to 120 seconds. So we say, but T is equal to 2 times 60, which is equal to 120 seconds. And having obtained that, we can now substitute the value of I as 0.6 and also substitute the value of T as 120 in order to get the quantity of charge in the circuit. And we do that. We say, therefore, Q will now be equal to, the current is 0.6, that means 0.6 times, the time is 120, that means times 120, which will be equal to, see how we will also do it. That's the basic foundation I'm talking about in mathematics. We can do this without going to the on-screen calculator to press and know the value, because that time you will use, when you are writing exams such as JAMB, you are battling against time. And so it means that the more time you waste, you are using the time you will use for the next question in a particular question. So you need to be time conscious as well. And while you are being time conscious, you also have to maintain accuracy. Okay, so to multiply this without calculator, I said before that when you are doing division, you move your decimal point to the left. Now we are doing multiplication, which is the reverse. We now move our decimal point to the right. And what does it mean? We have 0.6 here. We move the point from here to here, meaning that what we have now is 6 points. 6 points what now? 0, because there's no other thing there. So it means 6.0 times, and because we have moved our decimal place once here, we cancel this 0. Just as what we did here. When you move the decimal point to the left, you cancel the 0 here. And so in multiplication, once you move the decimal point, one decimal place, you cancel 1 0. And if it has 2 zeros, if you move 2 decimal places, you cancel 2 zeros, as the case may be. Okay, so we cancel this 0. And what are we having now? 6.0 times 12. And you know that 6.0 is the same thing as 6. So we simply have to multiply 6 times 12. And how do we do 6 times 12? Very simple. 6 times 2 is 12. What do we write? 2. And carry 1. And then 6 times 1 is what? 6. Plus the 1 we carried over. It will be what? 7. So what do we have? 72. And what is the unit of charge? The SI unit of charge is coulombs, which we represent with capital letter C. So it means that the quantity of charge in the circuit is 72 coulombs, while the current flowing in the circuit is 0.6 amperes. Okay, having solved the previous question and gotten the answers, I have an assignment for you, and it reads: 4 resistors, 1 ohm, 2 ohm, 3 ohm, and 4 ohms are connected in series in a circuit in which 2 cells, each of 1.5 volts, are connected in series. First question is, draw the circuit diagram. The second question is, calculate the reading of the ammeter. The third question is, if the current in the circuit flows for 5 minutes, calculate the quantity of charge in the circuit. Okay, so I will leave you with this so that you will do your assignments. If you have question, you also send your question. You know the channel. When I will take your questions, I will keep taking your questions, and then I will come online with a video telling you, look at the time we are going to do the corrections and answer your questions. So take time, do it, and then upload your answers. See you in the next class where we will do the correction and take your questions. Thank you.